You have made it to the very end. I am so proud of you if you've made it all the way to 16. As you can see, I have transposed it from the horizontal form to the vertical form for you. And let's go through it. If C, then A. If A, then B. Can we conclude something at this point? Pause the video, think for a moment, come back when you're ready. Can we? We can. Hypothetical syllogism, right? We have two conditionals, two if-thens. The back part of one matches the front part of the other, so they snap together to give us if C, then B. That's valid. C or D. Can we conclude something at that point? Pause the video, think for a bit, come back when you're ready. I don't think we can. There's nothing we can really do with this conditional C arrow B, or if C then B, and this or statement, C or D. So let's continue to read. If D, then E. Can we conclude something at this point? Pause the video, think for a bit, come back when you're ready. Okay, you might see it, you might not, but I'll tell you there is something that we can validly infer at this point. If you did not see it, pause the video, think for a bit, and come back when you're ready. Okay, do you see it now? If you do not see it, read C or D first, then read C arrow B, then read D arrow E. Think for a bit, come back when you're ready. You see it now? Either C or D, if C then B, if D then E, so either B or E. This is a complex dilemma, which is legitimately hard to see because I put the or statement in between the two conditionals, just for fun. Good, let me double check that. C or D, if C then B, if D then E, looks good to me. Now we are told not B. Can we conclude something at this point? Pause the video, think for a bit, come back when you're ready. And we can, right? I can conclude E. That's valid. With disjunctive syllogism, I either have B or E, but I don't have B, so I must have E. Now we're told if, as a unit, either P or Q, then the opposite of E, but E. Can we validly conclude the opposite of P or Q here? Think for a bit, pause the video, come back when you're ready. We can, right? This is valid. This is modus tollens because we have an or statement, excuse me, an if then statement. If front, then back. We have the opposite of the back, which allows us to conclude the opposite of the front, which is exactly what we did. So this is valid, huzzah! But I am not done. I want to give you a piece of knowledge at no extra cost to you. Let's take a look at this conclusion. And I'm wondering, what's that equivalent to? What's it the same as? P or Q? Is that the same as not P or not Q? Can we just distribute that tilde on through? Is it? Let's start with another kind of negated compound sentence. Let's think about a negated conjunction rather than a negated disjunction. And is symbolized exactly like you would expect with the ampersand. And what's that equivalent to? Would that be equivalent to not P and not Q? Think about that. Pause the video if you want, think a bit, come back when you're ready. Okay, I think it's always helps me to think of an English sentence here to kind of prime my intuitions. So let's suppose that I'm talking to someone and I'm wondering what kind of pets this person has. And I say, I think that she has both a cat and a dog. So I'm just going to change the P's to C's and the Q's to D's. So I make this assertion. Gloria has a cat and a dog. And you, who know Gloria, say, no, you have spoken falsely. It is not the case that Gloria has both a cat and a dog. That's what that is saying, right? It is not the case that Gloria has both a cat and a dog. Are you thereby saying that Gloria doesn't have a cat and she doesn't have a dog? Think about that for a bit. Come back when you're ready. I don't think you are, right? Because what if Gloria just has a cat and no dog, right? It would be true that she doesn't have both of them at the same time. What if she has a dog and no cat? It would be true that she doesn't have both of them. So this is saying something much stronger. This is saying that she doesn't have either. She has neither a cat nor a dog. Over here on the left, it's just saying she doesn't have both at the same time. She might have one, but not the other. So how could we symbolize that? Here's a hint. You don't want an and there. Can you think of what connector you might want there? Pause the video, think for a bit, and come back when you're ready. You see it? You want nor, right? If she doesn't have both the cat and the dog in her house at the same time, well, then she is either catless or she is dogless, right? She doesn't have them both at the same time. Very good. That is what that is the same as. So can you kind of distribute this tilde across an and? Yeah, as long as you change the and to an or. Has to kind of touch the and to and magically change it to an or. Now with that in mind, what do you think about this? Let's go back to the cat and dog again so that we can still use those intuitions. So instead of P, I will have C. Instead of Q, I will have D. Now this time, I say to you about somebody, Mitch. I don't know what kind of pet Mitch has, but I'm sure he has either a cat or a dog. And you, knowing Mitch, say to me, no, you have spoken falsely. It is not the case that Mitch has either a cat or a dog. He doesn't. Is that the same as this? Now, let's just think about generalizing what we learned at the previous example. You can distribute the tilde to the parts as long as you also change the connector. Here we change the and to an or, so what do you suppose we'll change the or to? An and might be a fair bet. Let's see if that makes sense. If you say no, it's not the case that he has either a cat or a dog. He doesn't have either a cat or a dog. Do you know that he doesn't have a cat? Yeah, you do. Because if he had a cat, then he would either have a cat or a dog, right? Do you know that he doesn't have a dog? Yeah, you do. Because if he had a dog, then he would either have a cat or a dog, right? Which he doesn't. So, behold, it works that way too. You can, in fact, negate an or as long as you kind of distribute the tilde to the disjuncts or the things that are ored, as long as you change the or to an and as well. And that, my friends, these two things together has a name. It's De Morgan's law, after the mathematician De Morgan. De Morgan's law. So, just for fun, De Morgan's law is both of them. Figure out what the conclusion here would be. If I were to say, write an equivalent sentence to this disjunction, what would you write? Pause the video, think for a bit, come back when you're ready. What do you have? De Morgan's law. We will distribute the tildes to the parts, and we change the or to an and. There we go. Very good. Excellent. Okay, so that is actually it for symbolic logic. This has been a lot of fun. I really like symbolic logic, and I hope you do too.